So let's begin with the next important concept, that is coordinate systems. Coordinate systems. There are different kinds of coordinate systems are present, but for our study, for this engineering electromagnetics, we are going to study three kinds of coordinate systems. What are those coordinate systems? First is Cartesian coordinate system. Cartesian, or this is also called as rectangular coordinate system. And second one is cylindrical coordinate system. Cylindrical coordinate system. Third one, spherical coordinate system. So one thing in the beginning itself, I try to make you understand that I will be taking these coordinate system, how much it is needed for your problem or for your studies, because it's a vast concept. Coordinate systems is not the thing how much I'm taking in one or other two lectures. It is not like that. It is a vast area, but still I am restricting myself how much it is needed for your studies, because I don't want you to get confused with all the things. It is just the things how much I am going to touch upon here, that is sufficient. Okay, so let me consider the first coordinate system. We'll start with the first coordinate system, that is Cartesian coordinate system, or this is also called as Cartesian coordinate system. This is also called as rectangular. Try to remember the alternative names also, because in the examination they may ask you represent or the given data is in rectangular coordinate system. Then you don't you should not feel like which is this new coordinate system. No, the Cartesian coordinate system and the rectangular coordinate systems are one and the same. So the rectangular coordinate system, how it is going to be represented? You just imagine the hollow cube. Okay, see. X, Y and Z. This is rectangular coordinate system. If any point in the space or in the region, if you want to quantify it, then you have to specify the coordinates. So what you need to understand, the Cartesian coordinate system is having three coordinate axes or three coordinates. So those three coordinates, this is having, it is having three coordinate points or the axes, which are x, y and z. X, y and z. These axes, these three axes, because we are representing in 3D dimensions, these three coordinate axes are mutually perpendicular to each other. So the angle between these axes, x to y, y to z, z to x, these are mutually perpendicular to each other. So better how you can draw this. And okay, one more thing, you also can represent this one as see, just let me take you try to understand the planes here. Coordinate axis which I have drawn is looking like similar, but you should understand, you should try to visualize the things. Okay, this is the plane. This is, let me mark it as a Z, and wait, I'll change the color so it will be more clear. Yeah, okay, this is Z, and it is Y, this is X, X, Y, Z. Let me point a point P, or consider a point P. This is point P I'm considering, which is having three components. Any point in the 3-dimension, it is having 3 components, and those 3 components are along 3 coordinate axes. Which are those axes? So P, it is having X component, Y component, and Z component. That is similar. This is X component, this is Y component, and this is X component. X, Y, Z components. It will be having 3 components. Okay, so in the problems, it is not necessary to represent in the coordinate system, or it is not necessary to draw where exactly it is going to be represented, but you have to understand by the coordinates, because in which plane it lies. Okay, now the word plane is, I'm using the word plane here. So what is that word plane? That is Z constant plane, Y constant plane, X constant plane. See, here what I suggest you here is, just remember the technical point here. Just X constant plane means that is nothing but that plane is parallel to YZ plane, and Y constant plane means parallel to ZX plane. X component is parallel to X constant, means that is, I'm really sorry, this is here, this should be, this is not YZ, this should be XY plane. This is XY plane, I'm sorry. Okay, X constant plane means that is YZ plane. So the point which is constant, you just have to understand that is in which plane the coordinates or the point lies. If the Z is constant, then it lies in XY plane. If Z is constant, it lies in XY plane. So where exactly the XY plane? This is XY plane. It has to be parallel to XY, right? This is XY plane. Just I'm drawing here. As I'm drawing it on a sheet, you cannot understand these two lines. Try to imagine in a cube, if I'm drawing here, the other part is this one. So it has to be parallel to XY plane. Which plane it is then? This is XZ constant plane. This is Z constant plane. So let me draw, take other color. Okay, so next I'll be drawing Y constant plane, Y constant. So how to draw the Y constant? That is nothing but that has to be parallel to ZX. See, here is the Z, this is Z plane, okay, and it is X plane, X1, right, ZX. So it is better, I'll draw here, it is Z, it is X, right? It has to be parallel to ZX plane. So this is the Z direction, this is x direction. Okay. Next, the third is x constant plane. X constant plane. So x constant means it has to be parallel to yz plane. See, this is y, right? This is y plane because y is okay, and this is z plane. So I should draw the plane here. Okay. Don't worry about the pictures if you are not getting. Try to watch the videos again and again. Even if you can't understand, just forget the pictorial things. You just have to remember, this is must and should. You have to remember x constant plane means that is parallel to yz plane. Y constant plane which is parallel to zx plane. Okay, z constant plane means that is parallel to xy plane. That is important. Okay. Now, see, till now I am talking about the magnitude or the pictorial representation of the points. But as I said, for the vector, direction is very much important, right? During a previous session, we have defined the unit vectors to represent the direction of the vector. So here also, for the vector or the vector which we are going to represent in a coordinate system, we are having three directions or the three axis points, that is along x axis, along y axis, along z axis. We need some support, or we need some vector support to represent the direction also, right? And the support which can be given by the new concept or the new vector, those are base vectors. Base vectors are nothing but the unit vectors. These vectors also plays the same role as unit vectors represent, because unit vectors, the magnitude of the unit vector was 1. Here the base vector's magnitude is also 1. The purpose of including the unit vector is to represent the direction of the vector. Here the base vector is also perform the same function, that it indicates the direction of the coordinate points. So how these base vectors, what are the base vectors here? Ax, Ay, Az. These are the base vectors, or I'll be representing it using cap, or you can also write it as a vector only. If you get confused with a cap, you can write it as arrow headed symbol, that is Ax, Ay, Az are the three base vectors along which coordinates? It is quite simple, x, y, z. Yes, x, y, z coordinates, x, y, z coordinate axis respectively. Okay. If anything, if the vector, say for example, if vector A is given, which 3ax plus 4ay, what does it mean? It means point 3 is along ax direction or on the x axis, 4 is on y axis, or the y component of a vector. So any vector which can be given as ax plus, sorry, here it's a scalar quantity because that is magnitude, ax plus ax, ay plus az. So these capital Ax, Ay, Az are nothing but the three components of vector A along the direction Ax, Ay, Az, which is represented like this. So This is very important in coordinate system, how to write a vector, how to find out the position vector and the distance between the two points in the coordinate system. That is important. Okay, so let me take the position and the distance vector. Position and distance vector. Similarly, again I am going to consider the coordinate system. X, Y, Z, the consider coordinate system. Point P is on coordinate system. Let me take point P. This is the vector P or point P of coordinates x1, y1, z1. x1, y1, z1. This is origin O. Okay. So, sorry, this is origin O. So, if I draw a line from origin to point P, if I draw a line from origin to point P, that is nothing but the r vector along the direction OP. Observe carefully what is the suffix I am writing, why I am writing OP, because the origin of the vector or starting point of the vector is at O point and terminating point of the vector is at P point, and the vector name I am giving as a R, so ROP. So what is the vector? R, this is vector symbol, and what is the direction? OP, right? Yes. So how will you write the vector? As I said, any vector can be represented, or it can be it is having three components. So this ROP is also having three components, that is x1 along x direction, that is x1, along y direction it is y1, along z direction it is z1. So x1, what is the direction of x1? That is a cap, plus, observe carefully, y1 along ay, plus z1 along z direction. This is nothing but the position vector. This is very simple. Once I take the problems, then you can understand why I am writing it in a vector form. Okay. So what is, just I have considered the point P of having x1, y1, z1 in the Cartesian coordinate system, and the three components of the position vector are oriented along three coordinates of the system, and that can be represented as ROP. Why I am writing OP? Because starting point is at the origin, P is the distance from origin, so I am writing it as a OP. In case if the vector starting point itself is P and it is terminating at O, then I have to write it as RORPO. Okay, so let's be very simple, let it be simple so that you can understand the complex problems. Okay, ROP is nothing but the position vector. ROP is, what is this? This is position vector. Okay, then what is the magnitude of the position vector R? So how to find out the magnitude? That is nothing but a very clear mathematical formula from your previous studies, that is ROP is a vector and magnitude is this. And how will you get the magnitude? That is x1 square plus y1 square plus z1 square, that is magnitude. Okay, this is the magnitude of the position vector. Please try to remember how I am writing, so you will understand the problems. This is magnitude of the vector. Okay, so this is when the one point is given. When there are 2 points are given or multi points are given, let me take the 2 points in the coordinate system. Okay, consider 2 points in the coordinate system x, y, z. There are 2 points I am taking. Q. Okay, just I am drawing the line here. This is the distance between the 2 points. Okay, here the coordinate points x1 comma y1 comma z1, and Q is at x2, y2 and z2. So let me consider point P at x1, y1, z1 and Q at x2, y2 and z2. So how will you write any vector? Just I have already told, any vector, just that is P as a vector. Let me take P vector is equal to x1, yes, ax plus y1 ay plus z1 az, and q vector x2 ax plus y2 ay plus z2 az. Now the distance vector is pq. I'm writing it as I want the pq vector, as you already had the op vector. See, just yes, here like you can give another name over here. Similarly you can give r vector from pq. So then the direction has to be, it is like this. If you write r vector from qp, then the direction will be like this. Okay, so sorry, what I am telling. Okay, now I want to get vector pq, vector pq. How I'll be getting? That is vector q minus vector p. So vector q is x2 minus x1. Can I write it directly? x2 minus x1 into ax plus y2 minus y1 into ay plus z2 minus z1 into az. This is pq, and position of pq, sorry, the magnitude of pq vector is similar to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square under the square root. So this pq vector, or the distance between two vectors, is, it forms the new vector, and that vector can also be called as separation of vectors. So this is position vector, sorry, okay, this is also called as separation vector, separation vector. Hope this is clear about vectors. Now how to find out the unit vector here? A PQ, because I need a direction, right? A PQ is a direction. I am writing these formulae for the direction of PQ. So how to find out that? A PQ is nothing but vector PQ divided by magnitude of vector PQ. This is the same thing which you have already derived in a previous session, how to find out the unit vector, right? Same formula. Okay. Hope this is clear. Let me brief out all the formula first. If any vector is given, say for example, if A is taken, then Ax will be confused. Let me take the vector P. If point P is defined in x, y, z, x1, y1, z1. Okay. So vector P can be written as, how will you write? x1 ax plus y1 ay plus z1 az. Okay. Then Q point is defined as x2, y2, z2. Then the position vector Q will be written as x2 ax, y2 ay plus z2 az. Okay. Now if I want the vector PQ, which will be given as Q vector minus vector P, which is x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az. So how to find out? Here A cap OP, A vector OQ. So how to find out? This is nothing but the OP and this is nothing but Q. So you can directly write it as P vector divided by position of P vector, Q vector divided by position of Q vector. Similarly, APQ will be given as PQ vector divided by position of, it is magnitude of PQ vector. These are the unit vectors. Using these formulae, we'll take a few examples so that it will be more clear. Take down a problem. Please make note of all the points. Don't sit idle and watch. You will not understand a single concept unless until you take a pen and paper calculator, just solve the problems. It will be more fun subject. So the first problem in the electromagnetic field theory we are taking, that is obtain the unit vector, obtain the unit vector in the direction from origin towards point 3, minus 3 and minus 2. See, what are the points given? Let me write down the given details first. Okay, so what are the given details? Things which are given as point, let me take point P is located at 3, minus 3, minus 2. One more hint is given, the direction is from origin. Direction is from origin means I'll be taking it as a O, and what are the coordinate points of origin? 0, minus 0, minus 0. Sorry, 0, 0, 0, because it is the coordinates of the origin is always 0. Obtain the unit vector in the direction from origin towards point P, they are asking. So what you need to find out? You have to find out, obtain from unit vector from origin to point P, right? Yes. Yes. So what is the formula for a position vector? It is OP vector minus divided by magnitude of the OP vector. So how will you write OP vector? These are the given points. So you have to find this thing. Now the solution. What is the solution? You can find out OP vector, right? So how will you find out OP vector? P vector minus O vector. Yes or no? P vector minus O vector. So what is P vector? Can you write? If you want me write it in a full more detail, I'll be writing. P vector is nothing but 3ax minus. Why it is minus? Because plus minus 3 into ay plus minus 2 into az. So it is P vector is nothing but 3ax minus 3ay minus 2az. How will you write the O vector? Is it necessary to write O vector? No, it is 0. Right. So anything P minus O, that is P minus O is 3ax. Yeah, I'll be writing now. 3ay 2az. This is P vector minus 0ax plus 0ay plus 0az. So it is 3 minus 0 is 0. 3ax minus 3ay minus 2az. This is OP vector. Okay. So what is the formula? You have to find out the magnitude of this OP vector. Under the square root of x1 square, that is a 3 square, plus minus 3 square plus minus 2 square, which is nothing but 9 plus 9 plus 4, which is equals to 22. The value of square root of 22 is 4.6904. But what is the question? You have to find out the unit vector from origin to the given point OP divided by OP. So what is the OP vector? That is 3ax minus 3ay minus 2az, right, divided by, that is 4.6904, because magnitude of the OP vector is this much. Now divide and calculate. 3 by 4.6904 is 0.6396ax minus 0.6396ay minus 0.42az. So what is the unit vector? The asked unit vector is 0.6396ax minus 0.6396ay minus 0.42az. This is the given question or the solution for the problem. Hope this is clear. The next problem is, take down the next problem. Second problem, 2 points A of 2 comma 2 comma 1 and b of 3 comma minus 4 comma 2 are in Cartesian coordinate system or rectangular coordinate system. Obtain, what you have to obtain? Obtain the vector from A to B, understand the direction, and unit vector directed from A to B. Okay. Now in the coordinate system, what is the given? Write down the given. See, every time I am not going to solve this much detailed steps, but these are the very basic or beginning classes. I am taking much time to solve these problems, but you should able to understand why I am writing the position vector directly. Okay, so given points are A of 2 comma 2 comma 1 and B 3 comma minus 4 comma 2. A vector can be written as directly 2ax plus 2ay plus az. I can directly write it as az because 1 is multiplied here and you can skip. I'll be right for your clarity. Okay, so B vector is 3ax minus 4ay. Hope you can understand why it is minus now, plus 2az. This is the given thing. What they have asked, they are asking two questions. One is vector AB, another one is unit vector of from the direction AB, right? So how to write vector solution? I'll be writing the solution. So how to write vector AB? That is vector B minus vector A. What is vector B? So directly you can write 3 minus 2, 3 minus 2 ax, okay, or you can take the vector B, you can write it the full vector B then vector A, but direct steps, it's better to learn direct steps, plus minus 4 minus 2 into ay, because minus 4 minus 2 plus the z component of vector B is 2 minus the z components of vector A is 1, that is az. So AB vector is equal to ax because 3 minus 2 is 1 minus, because minus of minus, that is going to be added, 4 minus 4 minus 2, that is minus 6 ay, plus 2 minus 1 is 1 az. This is the first solution, that is vector AB. Then what they are asked? They are asking unit vector of AB. So to find out the unit vector, what you need the vector AB and magnitude of vector AB. You already know about the vector AB, and magnitude is very simple. How to find out the magnitude? That is under the square root of 1 square plus minus 6 square plus 1 square, which is under square root of 1 plus 36 plus 1, that is nothing but 38. 38 square root is 6.164. 6.164. So this is the magnitude. So you can write the unit vector now, 1ax minus 6ay plus 1az divided by 6.164, which is equal to 0.162 AX. Try to verify the calculations. Minus 0.973 AY plus 0.162 AZ. This is the unit vector. Hope it is now more clear. After taking the second problem, hope it is much clear. Yes. So next I am taking the important and very interesting problem. Yes, let me solve 3 problems on this. Third problem. Write down the third problem. Okay, given 3 points, given 3 points, in Cartesian coordinate system. I am writing it in a short form. In Cartesian coordinate system, that is A of 3 minus 2 1 comma B of minus 3 minus 3 5 and C of 2 6 minus 4. What you have to find here is find the first one, vector from A to C, then unit vector from B to A. Third is distance vector from B to C. Then fourth is very important, and vector from A to the component which is midpoint, to the midpoint of straight line joining B to C. Here I am not solving the first 3 points, vector A to C, vector B to A, vector B to C. Directly you can solve those points, because what you have to do here, just you should find out AC vector, which is C vector minus A vector. Only thing you have to identify 2 minus 3. I am giving the hint, you have to write it, AX plus 6 plus 2 AY plus minus 5 AZ. Try to understand how these I am writing these things. You should get this answer. Then comes BA vector, that is BA vector, clearly mentioned, vector A minus vector B. Okay, vector A, 3 plus 3, that is 6ax plus 5, 2 plus 3, it is ay, 1 minus, so minus 4 az. You have to find out that. Then comes the BC vector, that is C vector minus B vector. Okay, I'll not giving the hint of a third point. Now just I am giving you the solution for the fourth one, which is simple, but you need a recall of previous formulae, right? So midpoint, how will you find out the midpoint of any line? Solution for the fourth one. How will you find out? Sorry. Midpoint of any line. Let's clear, that is B to C line. So how will you find out B to C line? Anything which is, say for example, 2 points, one is at B x1 y1 z1 and another point is at x2 y2 z2. So the midpoint will be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2 plus z1 plus z2 divided by 2. Using this formula you can find out the new coordinate points, right? Because what is the B? B is, okay, I'll write here B one more time, B and C. What are the B points? B points are -3, -3 and 5, and C points are 2, 6, -4. So how will you find out the midpoint now? Yes, using the given formula you can find out the midpoint, that is -3 plus 2, that is -1 here, right? -3 plus 2 divided by 2, comma -3 plus 6 divided by 2, comma 5 minus 4 divided by 2, which is -0.5, right? Because -1 by 2, that is 0.5. Then minus is plus, so plus 3 by 2 is 1.5, comma 1 by 2 is plus 0.5. These are the new points. What is the question here? Vector from A to midpoint of line joining BC. So try to write the midpoints, that is the vector of midpoint of line midpoint of BC, that is -0.5 ax plus 1.5 ay plus 0.5 az, right? This is the new vector. You have to find out. I'll be giving the name this as midpoint vector, so it is m. So what you have to find out? am vector, that is nothing but m vector minus a vector. So get this vector. The final answer I am writing. Try to solve this, and if you have any doubts, please comment or feel free to ask in the chat box. This is the solution for fourth one. So this is about the Cartesian coordinate system or rectangular coordinate system.